Computers are becoming increasingly integral to everyday life. Today's desktop computers are able to keep up with demanding tasks at homes, workplaces, and institutions. In the world of computers, hardware and software always need to keep up with each other to meet the needs of their users. In this program, we'll teach you what you need to know about 32-bit and multitasking as we approach the year 1996 in the 32-bit difference. If you are a current computer user or have considered purchasing one, there is a good chance you've heard the term 32-bit at some point. 32-bit technology can be very beneficial in today's computer applications as they grow larger and larger. 32-bit computing has been commonly available in desktops since the late 1980s, but its costliness required many software developers to continue writing their software with 16-bit systems in mind. These days, powerful computers are becoming increasingly more affordable, which is prompting the demand for more 32-bit software. The need for 32-bit software is further propagated by the recent release of Windows 95, the next generation of Windows that boasts greater stability and performance using 32-bit technology, along with greater ease of use in both hardware and software. What does 32-bit mean to you, though? In order to understand what 32-bit is, you first need to know what a bit is. In short, a bit is a single value that can hold a 0 or a 1, which is often referred to as binary. In a computer, a bit can be stored, read, and manipulated. A computer has many bits running through its CPU, memory, disks, and expansion cards, all for a variety of purposes like performing complex calculations, setting aside temporary data, reading from or writing to files, and displaying the contents of your screen. A series of bits can be used to represent a larger value, and this is done by adding numbers in a certain convention. Each digit in a binary value translates to a certain decimal value, with each successive digit being double the value of the previous from right to left. Let's take a look at the binary number 1101. This integer, or whole number, is 4 bits wide, so it is known as a 4-bit integer. As you can see, it is comprised of zeros and ones. When converting a binary number to decimal format, a 1 tells us to add a certain value based on the digit's position, and a 0 tells us not to. This figure shows the values of each digit in binary. Note that each successive digit can add twice the value of the previous. Starting from the right, the first digit has a value of 1 in decimal format. Since the binary value is 1, we add 1 to the decimal integer. The second digit has a decimal value of 2, but the binary value is 0. This means we don't add 2 to the resulting decimal integer. Moving to the third digit, the decimal value would be 4. This digit's binary value is 1, so we will add 4 to the resulting decimal integer. The final digit, which is equal to 8 in decimal, has a binary value of 1, so we add 8 to the resulting decimal integer. As such, 1101 in binary is equivalent to 13 in decimal. A 4-bit integer is capable of representing any of 16 possible values from 0 to 15. Wider binary integers can represent more values. An 8-bit integer can represent one of 256 possible values, and a 16-bit integer can represent one of 65,536 values. As more bits are added to a single integer, the number of possible values it can represent grows exponentially. This can be represented by a simple equation. which is 2 to the power of the number of bits. So, 2 to the power of 32 is equal to roughly 4 billion, meaning a 32-bit integer can represent one of that many values. The Central Processing Unit, or CPU for short, constantly works with binary values by placing them into different groups called registers. Each CPU has a certain number of registers which are of a certain width. Generally, a CPU labeled as 32-bit will have registers 32 bits wide. Therefore, they each can hold values up to approximately 4 billion. Of course, it is entirely possible to calculate numbers greater than 4 billion on a 32-bit CPU, but this requires storing numbers less than 4 billion and performing multiple operations in order to calculate the resulting number. 32-bit is only one factor in improving the efficiency and performance of modern CPUs like the Intel Pentium. Other technology in the Pentium is responsible for making programs much faster as well, including an architecture that allows the CPU to complete 2 instructions in one go. Also, just because a CPU is labeled as 32-bit does not always mean it only has 32-bit technology. In fact, the Pentium has an external data bus that is 64 bits wide, which can further improve the computer's performance in some cases. Computers will often store chunks of information in fast temporary storage components that are known as random access memory, or RAM. Any bits that are stored in RAM are not currently being processed by the CPU, but are set aside to be quickly recalled when needed. RAM is often measured in bytes, kilobytes, or megabytes. A byte is really just 8 bits organized into a group, which is often used to represent a character on a computer's screen. The prefixes kilo and mega are respectively used to indicate thousands or millions of bytes, so 1 megabyte is equal to about 1 million bytes. Although 1 million bytes is technically just 8 million bits, a byte is the smallest unit of memory that most computers can address or recall, so it is generally the accepted standard for measuring computer data. A CPU uses an address bus to locate the data it needs, which is stored in RAM. An address bus has a certain width depending on the CPU. For example, the 8286 CPU has an address width of 24 bits, meaning it can address up to 16 megabytes. As of now, this is a good amount of RAM for a Pentium computer, but in the coming years it will be too little for the ever-growing size of programs and files. That is where the 32-bit difference really comes into play. Modern 32-bit CPUs have address widths of 32 bits, meaning they can address much more memory, 4 gigabytes or 4096 megabytes. This limit has yet to be reached in even the most powerful Pentium computers, but even 32 megabytes of RAM in a 486 or Pentium computer can open up many new possibilities for large programs, and, as we will now explain, multitasking. In a computer, multitasking is where many computer tasks are run alternately or simultaneously. Alternate multitasking is a term we made up to describe switching between multiple programs and working on one at a time. This can be compared to writing a report and drawing something. Unless you can write with one hand and draw with another at the same time, you'll probably alternate between writing the report and doodling whales in between paragraphs. You can switch between programs running in the computer's RAM the same way. These tasks are not being done simultaneously, though. Simultaneous multitasking, as we call it, is where 2 or more tasks on a computer are being processed at the same time. Imagine you are cooking a hamburger on a stove while heating French fries in an oven and also listening to music on the stereo. While you're waiting for the hamburger to heat up enough so that you can flip it, the fries are also heating up and the music is playing the whole time. That's 3 things you'd hypothetically be doing at once. This is the kind of multitasking that modern CPUs are capable of performing, as well as what the new versions of Windows are bragging about. Those being Windows 95, a consumer-oriented upgrade for Windows 3.1x users, and Windows NT, a business-oriented version of Windows designed to take advantage of powerful computer hardware. Both Windows 95 and NT are being advertised as 32-bit operating systems capable of multitasking. However, earlier versions of Windows running on top of MS-DOS are capable of multitasking as well. In the next few segments, we will compare the multitasking performance of 3 versions of Windows: Windows for Workgroups 3.11, Windows NT Workstation 3.51, and Windows 95. We've set up a few procedures for testing the multitasking capabilities of each operating system. The first involves us playing a MIDI or MIDI music file, sending an email with an attached bitmap picture, viewing and printing a PowerPoint presentation, and also loading a vector graphic document in Adobe Illustrator 4.1. The second procedure is much the same as the first, only all the tasks are being performed while a floppy diskette is being formatted. The third procedure demonstrates multitasking with multiple MS-DOS windows opened, and each window running a different MS-DOS program. Windows for Workgroups 3.11 is actually quite capable of performing simultaneous multitasking to some extent. Our user will run the first procedure right now, and we'll let you see it for yourself. As our user was loading the aforementioned programs, the music playing in the background stalled several times. Whenever the user wants to do something else when he launches a program, he must wait until that program has finished launching. The user can perform actions like mouse clicks or keystrokes while a program is launching, but they are delayed until the program finishes launching. However, when the user requests a program to run a long task like printing a PowerPoint presentation, the user is able to work on other programs while data is being transmitted to the printer. Now let's run the second procedure. As mentioned earlier, our user will perform the same tasks, this time while formatting a floppy diskette. You may notice it takes quite a while for the music to start playing as the disk is being formatted. The user can still launch other applications and work on them, but such a simple task like formatting a diskette eats up a lot of the system's time and resources. Before we move on with the third procedure, let's take a look at the expected performance of a couple of MS-DOS programs running without Windows. Our programs of choice are Scream Tracker, a popular freeware music player and composer, and Alleycat, an old and simple game designed for the XT class computers of 10 years ago. As you may expect, both programs run at their expected speeds. It's interesting to note that some MS-DOS programs like Scream Tracker may come with a form of their own multitasking. A DOS shell can be launched on top of Scream Tracker, and the user can run a small program like Alleycat while the music in Scream Tracker plays. So now that you have some idea of how MS-DOS programs should run without Windows, we'll show you the performance of multiple MS-DOS sessions running simultaneously in Windows. For our MS-DOS multitasking procedure, the user will run Scream Tracker and Alleycat as shown earlier, along with two QBasic programs he wrote which infinitely repeat certain messages, and Xcopy, which will be used to copy all files of the Windows directory to a network drive for demonstration purposes only. Remember, don't copy that floppy unless you're doing it for your own testing purposes. As such, it turns out that copying that floppy is perfectly fine as long as you don't give it to someone else. Perhaps you could hold on to your floppy for backup purposes in case the original diskette disappears due to plastic-eating cockroaches. Under Windows for Workgroups 3.11, Scream Tracker runs just fine, albeit with improper graphics. That is, until the user clicks outside of the MS-DOS window to make it run in the background. The music stutters horribly. The user will now launch another MS-DOS prompt. Strangely, when even the slightest activity on another MS-DOS window occurs, like the cursor or underline blinking, or typing any characters into the prompt, the stuttering is alleviated somewhat. Running our infinite message program makes the stuttering mostly go away, so Scream Tracker plays the music at normal speed with some interruptions. Clicking outside of the window with the infinitely looping program brings back the stuttering problem, and running another infinitely looping program mostly stops it again. This unorthodox remedy does not work as well when running Xcopy at the same time, as that program takes significantly more CPU resources. Returning to the MS-DOS window, running Scream Tracker makes the music player run faster again, although now it will often stutter due to the other MS-DOS tasks running alongside it. Yes, you can also run multiple Windows programs simultaneously with multiple MS-DOS programs. Alley Cat can be run under Windows too, but the graphics are very slow in windowed mode, so to make the game run faster, the user presses Alt and Enter at the same time to switch to full screen mode. Like Scream Tracker, Alley Cat will also run significantly slower with other MS-DOS programs running. Windows NT is a version of Windows that does not run on top of MS-DOS at all. Rather, it has new underlying software designed with 32-bit in mind. Given a computer is powerful enough to run Windows NT smoothly, programs can often run faster than they would on Windows 3.1x. Multitasking performance in Windows NT is also superior, as you'll see now. Note that Microsoft Office 95 is used in place of Microsoft Office 4.3 here, as Office 95 is 32-bit. Although Office 95 is designed with Windows 95 in mind, it is also compatible with Windows NT 3.51. Our user zips through the procedure a lot more quickly, and he is able to launch multiple programs simultaneously without the delay seen in Windows for Workgroups 3.11. All the programs seem to run smoothly together, although Adobe Illustrator appears to slow down the system a little when zooming in to enlarge the plum graphic. This did not happen under Windows for Workgroups 3.11. Note that Adobe Illustrator is a 16-bit program. Multitasking while formatting a diskette is not an issue at all in Windows NT. Every program runs as fluidly as ever, apart from the slow drawing issue which Illustrator appears to have in Windows NT. Although Windows NT does not run on top of MS-DOS like Windows 3.1x or Windows 95, it does come with a layer of compatibility so that MS-DOS programs can run in Windows NT. MS-DOS programs are not guaranteed to be 100% compatible with Windows NT. Here, Scream Tracker is unable to detect the computer's sound card, the device which is responsible for creating sounds that play through your speakers or headphones. With no way to output sound, Scream Tracker becomes largely useless. Regardless, multiple command prompts can run much faster in Windows NT than they could in Windows for Workgroups 3.11. Xcopy is largely unhindered, but AlleyCat runs a little slower. Overall, Windows NT's multitasking performance is much higher than it was in Windows for Workgroups 3.11. If you want an operating system that has greater compatibility with MS-DOS and other 16-bit programs alongside 32-bit support, or you just want an interface that's easier to use than the program and file managers, you may want to turn to Windows 95 instead. Windows 95 introduces an entirely new interface rivaling that of the Macintosh operating system. Although we are an independent video production company not being sponsored by Microsoft, we can tell you one thing. The design of Windows 95, although somewhat lagging behind Windows NT in performance, is genius. From hardware to software, it's the most seamless experience we've ever had on an IBM Compatible PC. Although Windows 95 still runs on top of a special version of MS-DOS, it takes control of most of the hardware and software to provide improved device and memory management, as well as broader 32-bit support. In other words, a system running Windows 95 will be easier to configure and more stable than one running Windows 3.1x. For the serious multitasker, Windows 95 is the way to go. While running our multitasking procedures on Windows 95, we exploit some of the new features its interface provides, including shortcuts, the taskbar, and the start menu that everyone's talking about. We're going to make use of these features in our procedures as we test the multitasking capability of Windows 95, and you'll see them in action. For clarification, this is a shortcut, this is the taskbar, and this is the start menu. For the sake of saving time, we'll skip to the second procedure where we launch multiple Windows programs while formatting a diskette. Like in Windows NT, formatting a diskette does not hinder the performance of other programs. Launching programs in Windows 95 simultaneously does cause some delay, but noticeably less than in Windows for Workgroups 3.11. The user can continue working on other programs while the PowerPoint presentation is being printed. Zooming in Adobe Illustrator does not cause the slowdown problem seen in Windows NT. As we attempted to start the MS-DOS multitasking procedure in Windows 95, We had trouble getting Scream Tracker to play a different song in a window. It's not clear if this is a bug or just a consequence of Windows 95 overriding many parts of MS-DOS, but our user was eventually able to get some music playing with some fiddling. The best way we can describe it is that he opened the MS-DOS prompt, launched Scream Tracker, played the music, quit Scream Tracker, relaunched it, and then played the music successfully the second time. Of course, to make MS-DOS programs work as intended, Windows 95 users can just open the Start menu, click Shut Down, select Restart the computer in MS-DOS mode, and launch their MS-DOS base program from there. Under Windows 95, clicking outside the window running Scream Tracker will cause the music to stutter even worse than in Windows for Workgroups 3.11. If the window running Scream Tracker has enough conventional memory, the user can still open an MS-DOS prompt within Scream Tracker and run another command, all while allowing the music to play normally. Alley Cat performs rather well with other MS-DOS programs running, in full screen of course. Generally, MS-DOS graphics in windowed mode do not update as fast as they would in full screen. Windowed mode makes MS-DOS games unplayable, but it can certainly be useful with other MS-DOS programs that don't rely on real-time graphics to serve their functionality, such as for displaying graphs. As with the other versions of Windows covered previously, you can undoubtedly run Windows programs alongside MS-DOS programs in Windows 95. As you've seen, these three versions of Windows are all capable of multitasking, although the performance for each version is different. Windows NT Workstation 3.51 is the best of all three versions when it comes to multitasking performance, with Windows 95 only a little bit behind. If you still have Windows for Workgroups 3.11, you might suffice with it just fine. However, the new technology and interface in Windows 95 promises better overall computing in the years to come, especially for Pentium-based machines. Windows NT, on the other hand, delivers great power and security for our network applications here at JimboVideo. What do you think of these versions of Windows? Which ones did you use? Have you used a different operating system before, like OS2 or Macintosh system? We'd like to hear your thoughts so we can better suit our future videos to your interests. We encourage you to fill out the form enclosed with this video and mail it to the following address: 42220 Vapor Way, Atlantis, New Jersey 35007. Don't forget to mention if you were multitasking while watching this video or not. Thank you for watching.
Good morning, Virgo.